In this video, I will discuss a JEE Advanced PYQ. This question is based on the topics projectile motion, energy conservation, collision, and coefficient of restitution. Projectile is a mass thrown from the surface of the earth with some initial velocity at an angle theta. The projectile will move like this, it will attain a maximum height and come down. This is a parabolic path. Another type of projectile motion is the mass is thrown from a height h from the earth's surface. The mass is given a initial velocity in the horizontal direction. So this thing will move like this and hit the ground. So this distance is range, the distance covered in the horizontal direction, and this is the maximum height, and the flight time is t. Let us consider this motion. For this motion, the inputs are the initial horizontal velocity ux and then the height from which it is thrown. From that, we should be able to calculate the range and the time of flight. To calculate the time of flight, we will use this vertical motion is equal to ut plus half a t square between this point and this point. So between these 2 points, the displacement is the initial height h and initial uy is 0, half, and it will take the downward direction as positive for this particular motion. That will be more convenient because displacement is downwards, acceleration is downwards. So between these 2 points, these are the final points, the displacement is plus h, half, acceleration is g, and then the time to go from here to here is a flight time, t square. So from this I'll get the result. The flight time is 2h by g square root. Once you know the flight time, the range can be calculated as the horizontal velocity, which is uniform, into the flight time. So range the horizontal uniform velocity into the flight time. So flight time is known, so range is known. So with the inputs, the height from which it is thrown and the initial velocity, the time of flight and the range of this projectile motion is known. This mass, when it's coming down, it has got some velocity. So it has got 3 energies. One is the kinetic energy, which is half m velocity square, plus gravitational potential energy, which is mgh. This is the total energy of this moving mass or projectile, and this k is half m. M is the mass of this mass, and the velocity at any instant, let it be v square, and this v square can be written as vx square plus vy square, and vx is same as ux, is not changing. So the energy has got 3 terms: kinetic energy due to this horizontal motion, half m ux square, plus the vertical kinetic energy or the kinetic energy due to the vertical component of the velocity, half m vy square, and the potential energy, which is mgh. Total energy is constant because energy is conserved, there is no dissipation, and this component of the kinetic energy is half m ux square. Ux is not changing because there is no force in the horizontal direction. There is only force is the gravity in the vertical direction. So this is also constant. So as it moves down, height is going down, so potential energy will decrease and the kinetic energy will increase. So the energy will be exchanged between these 2 terms. Total energy and the kinetic energy in the x direction are fixed. And once it hits the ground, this mass can rebound, and if there is loss of energy, it's not a perfect collision. They'll reach a lesser height, say h1, and if it hits with a velocity v, it will rebound with a velocity say v final, and this surface will have a coefficient of restitution with the property of the surface E. And this coefficient of restitution, when it hits, the impact force is a normal reaction which will be perpendicular to the surface. So this, the velocity only the normal direction will change. The horizontal component of the velocity will not change. When it hits the ground, the velocity is same as ux here. The horizontal component, it's ux, and after collision also it's ux. Because during the collision, the impact force is in the vertical direction. There is no impact force in the horizontal direction. So ux it's throughout from here to here and from here to here. So this v final, that's after collision, the y component, that and this, so coefficient of restitution is v relative velocity by u relative between the two colliding bodies with a minus sign. One colliding body is mass, the second one is ground or the floor, which is not moving. So this velocity is 0. So this is nothing but the final relative velocity is Vfy by initial relative velocity is Vy. Before collision is V. This is V. This velocity which hits the ground. The horizontal component is ux. The vertical component is Vy with the minus sign. So after collision, the Vfy will be E times the velocity which hits the ground in the vertical direction. E is usually less than 1, so the velocity will decrease by a factor E after collision. So with these basic ideas, we can solve this JEE Advanced question. This is the question. A slide with a frictionless curved surface which becomes horizontal at its lower end is fixed on the terrace of a building of height 3h from the ground as shown in the figure. A spherical ball of mass m is released on the slide from rest at a height h from top of the terrace. The ball leaves the slide with a velocity u0 equal to u0 x cap and falls on the ground at a distance d from the building, making an angle theta with the horizontal. It bounces off with a velocity v and reaches the maximum height h1. The acceleration due to gravity is g and the portion of restitution of the ground is 1 by root 2. Which of the following statements are correct? Statement A, u0 is square root of 2gh x cap. B, v is square root of 2gh into x cap minus z cap. Option C, theta is 60 degrees. Option D, d by h1 is 2 root 3. It's more than one correct option, so I have to check all these options individually. You can pause and run this question. It's not a difficult question. So option A, you have to find this velocity. It's a smooth surface. So, and this is a small ball. So only there will be a translation kinetic energy. We can neglect rotational kinetic energy. So we can compare the energy at this point to the energy at this point. So energy at this point, it's released from rest. So it's mgh compared to, we'll take this as reference for this particular calculation. So mgh equal to the energy at this point, which is kinetic half m u0 square. So from this u0 equal to 2gh square root. So option E is true. And for option C, you have to find the at any point of that projectile motion, the inclination of this mass, this can be got as dy by dx equal to tan theta, and dy by dx is can be written as dy by dt by dx by dt, because dt dt cancel. So this is nothing but vertical component velocity by the horizontal component velocity. So to get this theta, the horizontal component velocity is known because it's u naught throughout. You have to get this vertical component velocity, which will be easily calculated because it's a projectile motion, we know the velocity at all points. One way to get this vertical velocity is to write the energy conservation between these 2 points. So the gain in the loss in the gravitational potential is mg. This loss of height, which is 3h, that will be gone into the increase in the vertical kinetic energy, ky. Because horizontal kinetic energy is same, it's half m u naught square here, so it's a half m u naught square. But the vertical component of the kinetic energy, which is half m v, this v, so this velocity b v1, before collision is v1, after collision is v. So v1 y component square, cancel m. So v1 y is 6 gh square root. So the vertical component velocity is known, horizontal component is same as u naught, and u naught is nothing but root 2 gh. So tan theta is vertical component velocity root 6 gh, and here the horizontal is u naught, it's root 2, so root 3, that means theta is 60 degrees. So option C is also correct. Option D, we have to find h1. So after collision, we can find this velocity, and if we do the energy conservation between this point and this point, loss of vertical kinetic energy will go in this increase in the gravitational potential, which is mgh1. So you have to find this velocity after collision. So after collision, the v1, the vertical component will be e times the velocity before collision. After collision it's vy, before collision it's v1 y. Sign is there, but we just need the energy, so just magnitude is enough. And before collision, the velocity is this much. And coefficient of restitution is 1 by root 3. And before collision, the velocity is root 6 gh. So it's 2 gh square root. So after collision, the vertical component of the velocity is vy, that is square root of 2 gh. So kinetic energy of this vertical motion, ky, it's half m vy square vy is this one 2 gh, that will go in increasing the potential energy mgh1. h1 is the height gained after the bounce. So h1 is same as h. And this range of this projectile that is involved there. So this range of the projectile we can relate to this flight time, the range of the projectile d, horizontal component velocity which is u naught into the flight time. Flight time we can get the vertical motion s equal to ut plus half a t square s is h, u is 0 plus half g t square. So the flight time is 2h by g square root. And u naught is, we got from the first option. First option is correct, so square root of 2gh. The flight time is 2h by g. H is the maximum height of this projectile motion, which is 3h. For this projectile motion, the initial height h is 3h. G and G will cancel. So this 3. So 2 root 3 into h. Root 2 into root 2 is 2. This h is 3h. So 3 will become root 3 and then h. And this is equal to d. And h is equal to h1. So from this I get d by h1 as 2 root 3. So option D is also correct. Option B, we have to find this velocity. So horizontal component of the velocity is around the x cap direction and the vertical is the positive z cap. So this is obviously wrong. But we can also get the magnitude of this velocity. Horizontal component is root 2gh, same as u naught. And the vertical velocity v1y that is vy. That's also root 2gh. So this one is actually this with a positive sign. So option B is not correct. If this was plus, then it is correct. So the correct options are A, C and D. That is the correct answer. This is what I explained here. To get U naught, use the energy conservation between the high point of release, energy conservation between these 2 points, this point and this point. So loss in the gravitational force is mgh. Let's see, gaining the kinetic energy half m U naught square. So from this, U naught will come out to be square root of 2gh and the direction is x cap. So option A is true. Option C, to get the angle theta, tan theta is the vertical component velocity Vy by horizontal component Vx, which is same as U naught, and that is root 2gh. To get Vy, use energy conservation between these 2 points, mg3h equal to half m Vy square, because the horizontal kinetic energy will not change. So energy conservation, the loss in the gravitational percentage is gain in the vertical kinetic energy. So from this V1y is root 6 gh. So tan theta is this vertical component by the horizontal component root 3, that this theta is 60 degrees. After collision, the velocity is Vy, before collision is V1y, and the normal component will be related by this coefficient of restitution. So it will change by a factor E, and E is 1 by root 3, which is less than 1. So this is root 2 gh. So with this, velocity after collision will gain a height of h1. With this velocity of v, it will gain a height of h1. So half m Vy square equal to mgh1. So mgh1 equal to half m vy square, which is 2gh. From this we get h1 equal to h. And to get the range, we need the flight time. Flight time we can get from AC equal to ut plus half at square. For this motion, u is 0 in the vertical direction because u is in the horizontal direction at t equal to 0. So for this vertical motion, s equal to ut plus half at square, u is 0. So s is 3h equal to half g, and this is flight time t square. Downward direction is taken as positive. From this, you get the flight time as 6 h by g square root. And range is d, which is u0 into t. And u0 is first option we got here, this one. And then the flight time is from here 6 h by g. So h will give h and then g will cancel. So root 12. And h is same as h1. So this d by h1 is 2 root 3. And the velocity after collision, here we'll have a horizontal component, the vertical component. Horizontal component is unchanged because after collision also it won't change because this impact force is in the normal direction. There is no force in the horizontal direction. So this vertical component is same as u0, but this horizontal component, the vertical component is along z cap, and this magnitude is vy, which is calculated as root 2 gh. So after collision it's root 2 gh x cap plus z cap, but in the option they are given minus. So option B is not correct.